Hello, let's look into today's Leetcode problem, minimum limit of balls in a bag. In this question, you are given with an integer array nums and another input called max operations. This integer array nums represents a collection of bags, and these bags will have some amount of balls in them. And if you look at this example, things will become more clear. So this integer array says that the first bag has 2 balls in them, the second bag has 4 balls in them, similarly the third one has 8 and the fourth one has 2. And you are allowed to do certain set of operations in this integer array. So what you can do is take any bag and decompose it into 2 bags. um, By that, what they mean is, let's take this example. In this, we have only one bag which has 9 balls in them. You take this bag, decompose it into 2 bags, and these 2 bags have balls set to 6 and 3. It can be anything like 1 and 8, 2 and 7, 3 and 6. It can be 6 and 3, or whatever it be. So you do this operation, and now the total number of operations that you can perform at max is max operations. In the end, what you want to do is return the maximum number of balls present in that integer array. After you do certain set of operations, right, you will come to a conclusion. You will come to a end result array, and the maximum element present in that array should be minimum. That's what they specify here. So for this example, we have come to this conclusion, and 2 is the maximum element. That is what we are going to return. For such problems, right? If you find a wording which goes like this, you need to maximize the minimum element or minimize the maximum element. Most of the time, the answer will revolve around binary search. So that's what we are going to do here as well. So you should be doing binary search on the answer. So the answer that we are going to return is the total number of balls, that is the penalty, maximum balls basically. So we will be doing our binary search on penalty. So I'll quickly walk you through the binary search approach on how things are done here. So initially we will set our low penalty value to be 1 and high penalty value to be the max of the integer array, that is 8. Then our mid value will be 4.5, which is 4, and we will see if a penalty of 4 is satisfied. So what you do is simply traverse through the array and calculate the number of operations to make the maximum element set to 4. So 2 when divided by 4, it's not divisible actually, so you can't decompose this element. So for this element, the number of operations required will be 0. Similarly for 4, the we want to set the penalty with a max of 4, and we already have a 4 here, so we don't have to do anything here as well. For 8, we can actually decompose it 2 times, 4 comma 4, and 2 again cannot be decomposed. So for this, we can say that we have a penalty value of 4, and we have not exceeded the maximum number of operations, which is 4. So we are good to go here. Let's try to now shrink the search space again, right? We want to minimize the penalty. So now our high will point to 3, and we will do the same thing for um, mid now. So high is 3, low is 1, 3 plus 1 is 4, 4 by 2 is 2. So right now we are setting penalty to be 2, and we will do the same thing again. So let me erase a few things, or else I'll draw it again. 2, 4, 8 and 2. Now our maximum penalty that we want to achieve is 2, and 2 cannot be decomposed further down, so 2 will be written as it is. 4 can be decomposed 2 times, so total number of operations used so far is 1, and 8 can be decomposed this way, 4 comma 4, which can further be decomposed into 2 comma 2. Now one more operation is used. One is for decomposing 8 to 4 and 4. One is for decomposing 4 to 2 and 2. And we can do it here as well. One and this 2 can not be further decomposed, and the total number of operations that we have used here is 4, which actually meets our maximum operation, so we are good to go here. So we will update our answer. Um, so we will try storing every possible penalty. If we are getting a minimum penalty when compared to the current penalty, then we simply update our penalty. So right now we have a good solution to. Let us try to lower the search space again. So this time h will be equal to m minus 1, which is 1, and for 1 we can, what we have to do is do a lot of operations, and your array will look like this, but those lot of operations will exceed 4, so it will be invalid, and in the end low will cross the low less than or equal to high barrier, and we will find to be the optimum solution. That's what we have done here. We have initially set the low to be 1, high to be the maximum element present, and we do a simple operation. I'll explain what the check functionality does. Whenever we find a valid penalty, we try to, we what we want to do is minimize, right? So we are trying to shrink the search space from high end, and else we are going to shift our search space from mid to high, basically. Okay, and whenever we find a good condition, good penalty, then we simply store it in our results. That's it. Okay, so what does our check functionality do? It simply calculates the total number of operations required and checks if it's lesser or equal to max operations. If yes, then we know what to do. One thing that you should observe here is I have written down this condition here. If it, we are going to iterate over the nums array, right? And if we find any element which is perfectly divisible by the penalty, then which actually occurred here. For 8, we have a perfect divisibility. So 8 can be decomposed into 8 divided by 4, which will give us 2. But basically, we are dividing this into one part only, right? So we, for such perfect divisibility, we reduce the operations. That's what I wanted to say. If it was 9, right, then 9 by 4 will give us 2, and 9 mod of 4 will not give us 0. So operations over there will remain the same. So we initially add the operations, and if we have perfect divisibility, then we remove the, like, we decrement the operations by 1. That's it. And we check for what we want to check, and yeah. So this is how the solution works. The only thing that you should keep in mind is whenever you encounter a problem which says maximize the minimum or minimize the maximum, try to think about the solution in binary search, and you should be good to go. So yeah, that's it for this problem. Thanks for watching. Bye bye.